solar and lunarary angular velocity. Now, the geocentric mechanics of the sun and the moon exhibit celestial trajectories known as the suntrail and the moontrail that these luminaries trace as they navigate their respective orbits within the sky. Now, these trails are empirical representations of the angular velocities that are associated with the sun and the moon, offering profound insights into their rotational kinematics and the underlying principles that are governing their celestial motions. Now, this not only elucidates the observable characteristics of the sun and moon's movements, but it also delves into the geocentric rotations that govern these motions that are very complex. Now, by using time-lapse technology, we capture the phenomena of the sunrise, and this is happening at all times, okay? But it's just relative to the observer, whoever's doing the experiment. The spiral trajectory observed in these images is emblematic of the sun's apparent motion as seen from Earth, based on where you're at. And the sun's apparent motion is a motion that is intrinsically intertwined with the concept of the analemma, that figure 8. Now, all the planets traverse the analemma at different relative speeds. Keep that in mind. The analemma, which is that figure 8 pattern traced by the sun over the course of a year, represents the sun's movement through the 12 zodiacal signs, the 12 constellations. The sun resides in each zodiac sign for approximately 30 days, completing its journey along the analemma ecliptic within 365 days. This spiral motion, particularly its circular component, is of paramount importance in our current analysis because it vividly illustrates the sun's consistent rotational behavior relative to an observer on Earth. The mathematical derivation of the sun's angular speed is rooted in the temporal framework of a single solar day, 24 hours. This period corresponds to the sun's completion of one full apparent rotation around Polaris. The constant angular velocity is denoted as follows. Omega sun equals 360 degrees per day. Time is measured with reference to the sun's consistent motion, which serves as the foundational basis for determining the days of the year and establishing dates for the calendar. This process is closely linked to the latitude and the directional component of harmonic oscillation within the sun's overall spiral motion. The complete circle of the horizon is a concept rooted in the early astronomical observations of civilizations such as the Babylonians and the Egyptians, who divided the sky into 360 equal parts based on their observation relative to the sun's path. The regularity of this motion was seen as a manifestation of cosmic order, a reflection of the greater, broader divine harmony that the ancient civilizations believed governed the heavens. Now, conversely, the moon exhibits a different angular velocity as depicted by the moontrail observed during moonrise. Unlike the sun, the moon's angular velocity is lower, resulting in a noticeable lag in its motion every day. Each day, the motion falls behind the sun by approximately 12.4 to 12.8 degrees, or translated to 52 minutes. So therefore, this lag is captured in the angular speed of the moon, represented as omega moon equals 360 degrees minus that 12.4 or 12.8 degrees, which gives you 347.2 degrees per day. So that's why anytime you look up in the sky, if you see the moon at a certain time, tomorrow if you were to look up in the sky and look for the moon, you're gonna have to wait an hour later to see the moon at that initial position. The moon completes a full revolution through the constellations within the span of what we call a lunar month, and that's equivalent to approximately 29.4 solar days, which is a little bit less. So that gives us the lunar phases. And the moon spends about 2 to 3 days in each zodiac at a time. So the equation for the moon's angular speed encapsulates the ancient belief in the moon as a more fluid and a changeable entity compared to the sun. The moon's lag behind the sun was often interpreted in mythological stories. It represents the moon's reflective nature and its phases symbolizing the passage of time and the cyclical nature of life. I've gone over how those two interactions have a relationship with each other. So the 12.4 to 12.8 degree lag per day reflects the moon's relationship to the zodiacs. The concept of the moon falling behind the sun resonates with the idea of the moon as a mediator between the sun's fiery positive energy and the Earth's material dielectric inertial plane, embodying the balance between the seen and the unseen, the manifest and the potential. The angular speeds of the sun and the moon through different magnitudes are essential to understanding the broader dynamics of geocentric celestial motion. These speeds not only determine the progression of time as we perceive it, but also influence the intricate patterns that we observe in the sky, the celestial motions. So, from our perspective, these equations are more than mathematical representations. They are symbolic of the ancient wisdom that viewed the heavens as a reflection of divine order, with each celestial body playing a distinct and purposeful role in the cosmic dance, the cosmic orchestra. The visual trails that are captured in these time-lapse images are presented more than mere aesthetic phenomena, but they are a testament to the precise and unchanging laws that govern the cosmos. In our ongoing exploration of celestial mechanics, the angular speeds of the sun and the moon offer a compelling glimpse into the rhythmic and harmonic nature of the universe, a rhythm that has guided humanity's understanding of time and space for millennia. So as you can observe, now I have meticulously documented my panoramic images from my visits to the Detroit River. That's where I go when I get my shots at, is the Detroit River. Okay, so if you guys are going to go and do this, I want to stress that it's really important to choose and dedicate yourself to a specific location if you want to carefully observe the analemma. So I'm asking for your guys' help from everyone else, because it's important to know the difference between what you see in the northern hemisphere and the southern hemispheres. In my videos, you see that the sun here, right here, that's in the northern part of the ecliptic for me, because I'm in Detroit, so I'm in the northern hemisphere. So I am closer to the Tropic of Cancer, while if you guys will see, the moon is more towards the middle on this other image down below. So the moon is probably going to be closer to Libra or closer towards Aquarius. I'm over there, okay? So that's from my perspective. So it's important to realize and to acknowledge, based on where you're at, the position of the sun and the moon and the constellations are going to be mirror flipped depending on which hemisphere you are in. So when you take your panoramic photos here, like if you were in the southern hemisphere, this northern observation for me is going to be over here for you in the southern hemisphere, and vice versa. See, and then this is why I want you guys to actually participate and post these kinds of images, because I'm trying to make comparisons of that figure 8. You want to keep in mind the analemma and understand how the zodiac signs are going to appear to approach you based on your relative location. So as I mentioned before, if you pay close attention to the moon and the sun's movement, you'll see that the full moon always shows up in the same part of the sky because of how quickly it moves. This is something you can't change. For example, in 2024, I've noticed all the full moons have been happening over here in the southern part of the ecliptic, while the new moons and the crescent moons are always happening over here in the northern towards Cancer.